Hello and a very warm welcome to the Rylands Lunchtime seminar series. My name is Stefan Hans from the John Rylands Research Institute and Library at the University of Manchester, and I'll be chairing this session today. The Rylands Lunchtime seminar series highlights the breadth and quality of our unique special collections and showcases world-class collections-based research activities across the university. And today's session is coming to you from various rooms, both in the historic John Rylands Library and across campus. In fact, most importantly, from the map room at the University of Manchester Library. And as usual, we will be showing some of the outstanding artifacts of our collections and presenting new research on them. Our seminar today is entitled Remapping, Past Weather and Climate. And before I'm going to introduce today's speakers, there are just a few things worth mentioning. First of all, this event is being recorded. It will be edited and made available on the John Rylands Library YouTube channel. Auto subtitles are available using your own settings, and we are using a Zoom webinar format. So that means that your camera and your microphone are disabled on entry. At the end of the session, we will have time for questions. There will be around 10 to 15 minutes. So if you would like to ask a question, could you please make use of the Q&A function? These questions will be then selected by me as the chair. They will be then conveyed to the panel, and we really have time to ask a few questions since we are aiming to stop around 1:45 p.m. So without further preamble, I would like to introduce our speakers today. Dr. Luca Scholz is lecturer in digital humanities here at the University of Manchester. Luca has an impressively international career with places like Stanford, Berlin, St. Andrews, Columbia University, Florence, Paris on his CV. He's interested in analyzing and questioning data in historical and humanistic inquiry. His work combines archival research and computational methods to study spatial history, intellectual history, and the visual representation of past weather and climate. Luca has published, among others, Borders and Freedom of Movement in the Holy Roman Empire with Oxford University Press, a monograph that charts the contentious ordering of movement through the lens of safe conduct, an institution that was common across the early modern world, but became a key framework for negotiating freedom of movement and its restriction in the Old Reich. And his new monograph project combines digital and archival evidence to develop the study of climate and weather in spatial history. A first article on this subject is forthcoming in Past and Present, and you're going to hear more about this in the lecture today. Presenting with Luca is our very own Donna Sherman. Donna is the map curator at the John Rylands Research Institute and Library and has over 15 years of experience of working with maps and atlas collections at the University of Manchester. She is the lecturer secretary and a trustee of the Manchester Geographical Society. She's also a member of the British and Irish Committee for Map Cataloguing Standards, and she's also an active member of the Map Curators Group of the British Cartographic Society. It's a real pleasure to have you both here. So thank you both for talking to us today, and over to you.
Good afternoon, everybody. I'm going to start with just by telling you a little bit of background about the map collection actually here at the university. So the University of Manchester map collection comprises about 150,000 map sheets and over 1,300 atlases. It's the largest map collection in the north of England. And it's also the largest university map collection in the country after Oxford and Cambridge. The collection originated in the 1920s with the establishment of a Department of Geography at the Victoria University of Manchester. In fact, Manchester was one of the first universities in the country to offer an honours degree in geography, where geographical science was taught as an academic subject in its own right. From the 1920s onwards, the collection expanded significantly to support the teaching, learning and research needs of the department, as well as incorporating collections from private collectors and later the collections of the Manchester Geographical Society. The collection continued to grow within the School of Geography throughout the 20th century until it was relocated to the main library in 2007. It became part of the university's special collections in 2012. The collection itself offers an extensive range of topographic and thematic mapping for the UK, as well as wide-ranging coverage for the rest of the world. The collection is a valuable source of geospatial data spanning the 16th to the 21st century and offers a wealth of primary sources for a wide range of subject areas and disciplines. There is no denying that the use of the collection by geographers has declined somewhat over the last 10 years due to the rapid advancement of digital mapping and changes in course content. Web mapping and geographical information science, or GIS, have replaced taught modules on the history of cartography and traditional cartographic design. However, the last 20 years or so has also seen more and more people from different disciplines regarding the maps as important primary sources, historical documents, and objects of material culture. Looking at maps through a critical lens can reveal much about the societies in which they were produced and demonstrate how legacies about our perception of the world and its people have been formed. Currently, our collection is regularly consulted and used in teaching sessions by those studying history, architecture, English and American studies, and digital humanities. More broadly, our collections relating to climate, geography, nature, and medicine are becoming increasingly popular in research studies on environmental history, climate change, and the resulting impact on human societies. Furthermore, I am optimistic about recent plans to see geographers returning to the map room for sessions on cartographic design. This reflects the current and very real concern amongst cartographers about the ease with which poor and often misleading maps can be created and disseminated by almost anyone with access to the internet and a laptop. Professional organisations such as the British Cartographic Society are campaigning hard to improve standards in cartographic quality and urge commitment to effective and responsible mapping. Consulting physical map collections and examining both historical and modern printed maps is a good place to start. For example, how can we learn from cartographic methods and techniques which were successful in the past? How can we use this information to create more effective and engaging digital and paper maps today? How can we create new ways of visualizing data and interpreting space? And how can we map diverse human experiences more effectively and responsibly? In a moment, we'll hear about how Luca has utilized some of our collections in his research. But first, I'll just give a brief overview of the items on display today, which include two 19th century meteorological atlases and plates from Atlas der Schweiz, a national atlas of Switzerland published in 1978. So the first item that we're going to be looking at today is Dr. Julius Hahn's Atlas Meteorology, published in Germany in 1887. This was the first attempt really at compiling a systematic atlas of meteorology, and it first appeared as a small part of the larger Berghaus Atlas. It contains 12 plates of 60 maps and represents a summary of research for that period. Just 12 years later, we have a much more kind of comprehensive kind of approach, and we'll see that with Bartholomew's Atlas of Meteorology from 1899. This represents the position of meteorology at the close of the 19th century and the great practical advances in the study of climatology and the accumulation of scientific observations during that period. 400 maps document weather and climate across the globe, summarizing observational data relating to temperature, pressure, winds, cloud, sunshine, rainfall, and storm events. The maps represent in graphic form the results of data captured from many millions of observations taken from over 30,000 meteorological stations across the world, some data spanning up to a 25-year period. The third item that we'll look at today provides examples from 20th century climate mapping. And we'll look at two plates from Atlas de Schweiz, published in 1978, and featuring maps created by Edward Imhoff. 86 pages of this item contain maps, diagrams, charts, and profiles. The maps have a fundamental scientific basis, resulting from Imhoff's effective collaboration with Swiss scientists. But they're really brought to life by Imhoff's expert cartographic skills and artistic skills. Imhoff minimized text within the maps, allowing full attention to graphic details and representation. Finally, for anyone interested in further historical study of meteorology, the published works of naturalist and climatologist Alexander von Humboldt are well represented in the university's special collections, as well as archives relating to the university's very own meteorological observatory at Whitworth Park. And that's it from me, and I would like to pass you over to Luke now so that we can have a look at some of the objects that we've just been talking about.
Yeah, thanks a lot. Thanks a lot for the invitation and for the kind introduction, Stefan. And thanks, Donna, for introducing the maps. All right, yeah. So maybe I'll say a couple of words about where this is coming from, and then we can look at these maps in a bit more detail and some other maps as well. So this research is an attempt to meaningfully engage with an environment that has been largely absent from spatial history and the digital humanities, and that is Earth's atmosphere. Recent decades have witnessed an increased uptake of digital mapping as a method of research in history and across the humanities. And while the methodological and thematic concerns of spatial history have expanded, most of the maps created in this domain visualize data of phenomena on the surfaces of land and sea. Now, this disconnect, if you want, between atmospheric and terraqueous cartography is by no means unique to the spatial humanities, but it reflects a much broader division. Marc Montmonier once described the atmosphere as a, quote, a province apart, invisible and largely ignored by those who study the design and use of maps. Now, this project that I'll talk about today builds on two strands of scholarship. One is the cultural history of weather, so an effort to diversify, to expand, and to emancipate the study of weather, climate, and atmospheric environment in the humanities. Importantly, this is a lot of this work has been done by Vladimir Jankovic, with whom I am collaborating closely, and who is also here at the University of Manchester. The second strand is what you could call critical cartography and critical and historical data visualization. The idea is that the arguments made by maps rely as much on the visual choices made in the graphic choices made in the process of visualization as on underlying patterns in the data. So this is scholarship that highlights the screen as a site of work in which the humanities have an important mandate. And some of the scholars on whose work I build here are Bill Rankin, Anne Kelly Knowles, and Johanna Drucker. And the idea is that by borrowing rather than forging their own visual language, the environmental humanities forego a compelling mode of generating, of questioning, and of communicating their knowledge. And that a creative and careful consideration of the cartographic language used to present environmental data has considerable potential for enhancing work and research in this field. So my presentation is roughly divided in three parts. We'll look together at the maps that Donna just introduced to highlight some cartographic conventions in meteorology and climatology. I will then discuss some more recent uses of what I call algorithmic layering, and I'll conclude with a case study that, in a sense, attempts to map weather as it was understood and confronted by contemporaries. So obviously, let's begin then with the maps that Donna just introduced, the maps that are held by the in the map collections, and I hope that everyone is able to see the map room window that is, I assume, pinned as well. Yeah. So obviously, meteorological and climatological maps constitute an incredibly broad, diverse, and sophisticated genre of cartography. And it's impossible to discuss it in any depth in a talk like this. So what I would rather like to do here is to point out a set of shared visual conventions that showcase a physicalist vision of weather, which detaches the atmosphere from the human environment. And perhaps we can begin with Julius Hans' Atlas der Meteorologie, which we are currently, which we're seeing here, which we are seeing here in detail. Now you'll notice on this atlas page, on the margins, on the right and left, synoptic weather charts, which are perhaps the most common spatial visualizations that we encounter in historical climatology, and in fact in meteorology at large. They employ contour lines and depression tracks to plot atmospheric pressure systems and weather fronts, and they employ an established symbology to represent cloud cover, wind speed, wind directions, air temperature, barometric pressure, and weather conditions at specific locations. Now, if you look at these maps as a lay viewer, however, you might struggle to decode some of the map's visual conventions, which tend to reinforce the exclusive expertise of climatologists and make these visualizations powerful rhetorical devices. Indeed, some scholars of scientific graphics have argued that synoptic views of natural systems serve to imply that their authors have fully comprehended or even controlled the system. Perhaps we can move on to the other atlas, Donna, the Atlas of Meteorology, the plate with the storm tracks and the storm frequencies. Yeah, perfect. So synoptic weather charts, like the ones that we have just seen, are called synoptic because they display different parameters of Earth's atmosphere over a large area at a common point in time. Now, of course, the variability of weather and climate over time is a key concern in the study of climate, and climatologists have long employed a finite set of strategies to map the fluctuation of weather and the variability of climate. And one of the most common ways in which particularly historical atmospheric cartography addresses time variance are small multiples, and you can see an example of this here. So this is a bit like snapshots in time. These maps can be arranged in what are called small multiples to show the temporal trajectory of weather and climate. Now, if we turn to, I think it was plate 30, Donna, of the same atlas, and then perhaps zoom in. Let's see, zoom in a little bit. Yeah, so a bit to the left. Mean deviations. Yeah, mean deviations from mean pressure. We can see another way in which historical atmospheric maps, but also generalist cartography, meteorological cartography, addresses temporality. And this is through what William Rankin has called the historical variable. Rather than visualizing events occurring in a specific amount of time, the historical variable shows the result or the summary of a historical process, for example, by comparing 2 points in time. And this mode of presentation aligns well with an understanding of climate as a reference against which to compare specific events or periods. And even though they are traditionally published in static rather than in dynamic formats, I think it becomes clear in these examples that historical atmospheric maps regularly represent the atmosphere as a variable environment. Now, by representing, and you will have noticed that, you will see this on these maps, on the ones we showed previously, by representing the atmosphere over areas of millions of square kilometers, they also represent weather as a phenomenon that transcends individual landscapes and places and must be understood at the continental, if not the global scale. And while this is often a direct reflection of the limited availability and also granularity of data, the resulting maps sometimes contrast not just with how weather often has been understood and observed by historical subjects, but also with contemporary scholarship in the atmospheric humanities, which often understands weather as an integral part of the landscape. Now, perhaps we can go to the Atlas der Schweiz and to, I think it was plate number 2, because there are notable exceptions. And one of these is the map that we'll show in a second, which is a map of typical wind currents in the Swiss Alps. So so here we can see this map. So what we see here is that obviously we have a larger scale, so the map covers a smaller area, and there is a much stronger emphasis on the connection of weather and landscape. And in fact, wind is by far the most common atmospheric phenomenon that we find on maps that accompany scholarship in history and the humanities. So if non-meteorologists map the atmosphere, it is usually through winds. And historians tend to represent wind through vector features such as arrow, often with a more qualitative focus on direction rather than, for example, in an attempt to quantify velocity. And we can see that in this map here very nicely as well. Now, if we move to plate 4, Donna, the one that says Frühlingseinzug, yeah, here we are. We see what I think is perhaps one of the most important characteristics of the maps reviewed so far, which is that which concerns the way that they treat the atmosphere as detached from the world that it immerses. On synoptic maps, atmospheric events are commonly foregrounded against a dimorphic background structured by coastlines that bound land from sea. Atmospheric and phenological data, so that is information that relates to seasonal changes in plants and animals, rarely make it onto the same maps. And even scholars who emphasize the interactions between atmospheric phenomena and events on the Earth's surface rarely make these connections visible. And what we're looking at here is a good example. This is a map of dandelion bloom as an index to the beginning of spring. So we see a color palette that goes from red to blue, and that mapped onto, so going from late March to mid-May. And this, in a sense, is a relatively rare intervention, a relatively rare visualization, where we have an interaction between the atmosphere and the non-human environment. And this typically tends to take a graphical form in this cartography. In contrast, the even fewer interactions between weather and human society tend to be expressed verbally. And that is really a characteristic that these maps share with the wider genre of contemporary climate change graphics, which are often primarily concerned with biophysical environments and tend to elide human geography. Yet recent decades have seen sustained efforts at realigning human and non-human history. Environmental historians have found new ways of articulating climate-human interactions, for example, by focusing on social impacts and the cultural interpretation of climates. So the question that I'd ask then is, are there cartographic strategies that avoid the separation between the human and the non-human geographies of weather? And at this point, I will switch over to my set of slides. So I'll try and share my screen. Hopefully this will work. I hope this is visible now. Let me know it's not visible. All right, okay. Now, if we look at maps of historical atmospheric phenomena that are common in contemporary digital scholarship in the humanities, they often employ a somewhat different visual language. In meteorology and particularly in historical climatology, climate and atmospheric data are often the end result of a research project. Now, in the spatial humanities, there's often less of an emphasis on the generation of new data than on its exploration in order to advance historical argument. And visually, climatologists and climate historians tend to map atmospheric phenomena in isolation, while spatial historians and scholars in the humanities dedicate their work more on the premise of merging different kinds of data. So let me show you what I mean with that. The most important technique that enables this combination in recent years comes from computational fluid dynamics, which is essentially a numerical approach to model and analyze problems involving fluid flow. So think of the aerodynamics of aircraft, for example. Now, historical climatologists have used these modeling techniques at least since the 1960s, but in the humanities, computational fluid dynamics is now being used at scales much larger, so of the city or of the village rather than that of the continent, in an effort to understand the interactions between human and non-human environment. What you're seeing here is an image that I've taken from a recent study published in the Journal of Political Economy that combined modern wind data with the location of industrial chimneys extracted from ordnance survey maps, terrain models, census data, and pollution deposits to highlight the role of wind and air pollution in explaining the deprivation of the east sides of former industrial cities in England. So with the eastward direction of the prevailing winds pushing industrial emissions into eastern neighborhoods. And a statistical analysis led the authors to conclude that these historical patterns of pollution can partially explain modern neighborhood segregation. A second example that I won't go in much detail, I just want to show you the kind of cartography that comes out of it, comes from an article by a Japanese scholar, Muneyuki Natsume, who studied a model of 19th century Japanese village with computational fluid dynamics to assess the effect of woodlands and hedgerows on wind reduction in rural settlements that were typical of the time. And to give you a third example, more recently, researchers from forensic architecture and UCL used meteorological data in fluid dynamic simulations to investigate the exposure to airborne pollutants and what they call the chemical gassing of historically Black communities on a particularly polluted stretch of the Mississippi River in Louisiana. Now, and I've included links to these if you want to look them up. If the maps that dominate traditional climatological and meteorological cartography and contemporary climate science, but also model-driven climate history. So the maps that I've shown you in the first part of the talk, if these maps eclipse or abstract human agency, the algorithmic maps that we've seen here foreground it. All three examples employ computational fluid dynamics algorithms to show how human agents affect the atmosphere through landscape modifications and emissions, causing important and long-term consequences for those who live downwind. At the same time, all three maps discussed here present the interaction of atmospheric environment and human society in physicalist terms, that is, as measurable and computable as wind speeds and directions, particle concentrations, or fluid friction. Non-physical categories, so elements like interpretation, emotion, or experience, play no role in these maps. Now, in their emphasis on quantitative accuracy and statistical inference, these maps are far removed from the terms in which contemporaries describe their interactions with the atmospheric environment. So as such, these maps, one could say, offer an etic rather than an emic account of atmoterrestrial environment. That means they take a modern outsider perspective that reduces human atmosphere interactions to the physics of fluid flow. And the question then is, can we create maps of past human atmosphere interactions in an emic perspective? Meaning, can we map the atmosphere from an insider view as a socio-political space understood and experienced in historically and geographically specific terms, rather than as a timeless, universal, and strictly physical environment? And this is what I want to explore in the last part of this presentation. Now, this is a case study that I would like to show you on the history of storm cannons in Alpine Europe. In the agrarian areas of 18th and 19th century Europe, hailstorms and other severe weather events could destroy the fruits and crops of an entire season in a matter of minutes. In fact, some of the oldest insurance models there were designed to protect communities against the dangers of hail. But farmers also deployed more active strategies, such as ringing church bells or shooting at the sky to dispel clouds and avert storms. One practice that was particularly common in the Alpine region was to shoot at the clouds with empty cannons and rifles. And the assumptions about the mechanism at work there varied. Some believed that the cannon shots could push the storm clouds away from fields onto forests and uncultivated lands, and others suggested that metal bullets could attract lightning from the clouds and thereby somehow causing them to discharge. Communities developed elaborate tactics on where these cannons should be positioned and when the shots should be fired, and theories about which geographic features generated or attracted storms, such as lakes, for example, mountains or bogs. And the practice engendered heated debates, not just among scholars, but it was not uncommon that neighboring towns and villages would accuse each other of having sent storms their way. And let me show you what this meant concretely through a case from the early 1770s in the borderlands between Salzburg and Bavaria that I've tried to map out. Now, the situation was that subjects of several villages and towns belonging to the Prince-Bishopric of Salzburg petitioned their authorities to let them continue shooting at the weather after the practice had been outlawed a few years earlier. And the argument made by the peasants in their petition was a spatial one. It's difficult to appreciate for readers unfamiliar with the region. So this and the following maps are my attempt at visualizing the peasants' narrative. The petitioners, who lived in Holzhausen and in Ringham, so the two villages you can see at the center of the map, wrote that the storms usually moved from two nearby lakes in the direction of the mountain called Teisenberg, but that they were always repelled by the strong weather blessings performed by the clergy in the Högelwörth Abbey. The storms then either stood still in the area around Teisendorf, or they moved towards their two towns, so Holzhausen and Ringham, and then further towards Waldorf, Saaldorf, and Haunsberg, which all belonged to the Prince-Archbishop of Salzburg. Now, the farmers claimed that previously, when they were still allowed to operate their cannons, the cannons of Ringham and Holzhausen and Saaldorf had been able to either dispel the storm clouds or direct them towards the mountain close to Teisendorf, where the precipitation fell into the forests. And now that they were prohibited from shooting, the storms went back to take their old course. Now, the described storm track suggests what one could call a billiard ball vision of storms, where physical and apotropaic interventions such as storm cannons and weather blessings deflected storms from their natural course. These interventions constrained the space within which the storms could move and determined their course. This atmoterrestrial force field described by the peasants was informed by more widespread assumptions around the storms, assumptions about interactions of storms with the terrain underneath. Exhaled from the lakes, drawn in by the mountains and dodged by the weather blessings to the south, the storms could only escape westward into Salzburg's heartland. So the weather space emerging from the petition, and this is what the next map tries to illustrate, was not just informed by contemporary beliefs about atmoterrestrial interactions and religious forms of storm depression. If one takes into account the political geography of the region, a further layer emerges. The petitioners claimed that their precarious position was exacerbated by neighboring towns that were allowed to continue shooting. So if we wish to understand this narrative, we also need to take into account the political geography of the region, which suggests a political explanation to this, to the physical and spiritual geography discussed in the sources. The cannons in Traunstein thus push the storms even more vehemently towards the petitioning towns of Ringham and Holzhausen. And in Ostermeeting, a town to the north that is not on this map, the shooters also do not let any storms across the water, in the words of the petitioners, thereby further locking the storm's path. Traunstein and Ostermeeting, the shooting towns that locked the storms into the north and the northeast, were both situated in the electorate of Bavaria, in close proximity to the border with Salzburg. The petitioners thus framed their use of the cannons as a question of self-defense against their Bavarian neighbors, a type of argument that one can find in other similar cases. So the argument that the petitioners were making was also not just about protecting their own communities. They claimed that their shooting could protect the Salzburgian territory further inward. And while it's possible that the petitioners believed that the storms followed the patterns that they describe, it is also conceivable that this entanglement of atmospheric and political geography was a deliberate attempt to frame their request as an interpolity dispute that was more likely to garner the authorities' attention. Either way, the Salzburgian subjects along the border were eventually allowed to operate their cannons under the condition that they only pointed them towards Bavaria. Now, it's clear that the atmoterrestrial geography described by the petitioners was informed by beliefs and structures specific to their cultural and political context. At the same time, one cannot reduce the geography of the weather wars to cultural beliefs and political tensions alone. The physical tracks of the storms described by the petitioners are consistent with the region's climatology and the westerly and southwesterly winds characteristic for most hailstorms in this area. And I'm being told that I need to rush up, so I'll quickly show you this map here, for which I obtained radar data from a Swiss climatologist, and after transposing this data into a usable format in Python, managed to display it on maps here. And the data that you're seeing here includes the centroids of different storms bearing large hailstorms, so very large hailstorms at 5-minute steps collected over the last decade. And the map shows that the storms that contemporaries were contending with were elongated, fast-moving shapes. Most severe hailstorms, in fact, in the Alpine region follow relatively linear trajectories, but storms can occasionally take sharp turns and change directions in line with the storm dynamics that were described by contemporaries. So to the petitioners, the irregular morphology of storms resulted from the interplay of human and non-human forces, and this juxtaposition of climatological data and archival narrative can spotlight the extent to which the storms of the late 18th century were socio-natural hybrids. All right, so let me conclude. Focusing on a chapter in the history of weather modification and taking a long view of how meteorologists, historians, and their collaborators have mapped atmospheric environments, we asked how past weather can be mapped as a sociocultural construct rather than just as a physical process in the exclusive remit of science. The concerns of historical climatology have long favored a longue durée, flat, small scale, and isolated perspective on the atmosphere. More recent studies employ computational fluid dynamics to show how human agents have affected atmospheric environments through emissions and modifications of the built environment. At the same time, they remain committed to a modern, physicalist perspective that reduces human atmosphere interactions to the physics of fluid flow. And then the last part of this talk, I presented my attempt at a more humanistic cartography that attempts to represent past weather as it was understood by contemporaries. Now, this was a single case study, but I think there's a much wider range of possibilities, and I'm currently exploring those with my colleague Vladimir Jankovic. I think the wider proposition here, and that's my last point, is that the visualization of environmental data can be sterile, it can be totalizing, it can even be a form of planetary voyeurism, but it doesn't have to be. My attempt at making a visual argument that bridges the split between human and non-human history to reconfigure weather as a part of the landscape and take seriously the view of historical subjects perhaps shows that that while atmospheric mapping is no panacea, and while this medium has obvious limitations, I do believe that the digital humanities have an important role to play in expanding the remit of historical atmospheric mapping beyond the graphical repertoire of atmospheric science. All right, thanks a lot.
Thank you so much, Donna. Thank you so much, Luca. Really fantastic presentation that brings cartography, environment, spatial history, human, non-human history, and methods into a really meaningful conversation. And what amazing maps you've shown us, a really inspiring case study. So both of you, thank you very much. It's my role now to remind everybody of the Q&A function to make use of this opportunity to ask your questions. A few things have come through already. I'm going to pass that on. Lots of praise that I will share with the speakers afterwards and that I will forward later on. A few questions have been regarding pre-knowledge. So how well, for instance, do you need to understand fluid dynamics before you can engage in such scholarship that has been outlaid? I think that's a question for Luca, presumably.
Yeah, how well do you need to understand fluid dynamics to engage with the scholarship too? Well, I think to read the scholarship, I don't think you need to know much at all. So these articles are fairly accessible. Perhaps the article in the Journal of Political Economy is a little more technical. It's authored by economists, but the gist of it, I don't think you need in-depth knowledge. Of course, if you want to produce some of this scholarship, yeah, that it gets a little more. It gets perhaps a little more technical. Even there, my sense is that it might be depending on how elaborate and how complex you want to do this. I think it should be something that should be quite accessible.
Thank you. Then there has been a question, I guess that's for Donna. You've mentioned the 150,000 maps in the collection. So there's a question about the potential of this research and its wider applicability in light of the cultural specificity of maps. So thinking about the application of such research and methods also for instance, maps produced in Asia and other continents, which options, which potential do you see as a curator?
Yeah, sorry, I can't quite see the content of that question. Was it more about the
I think it's about the wider applicability of digital methods and their role for curators in unlocking non-European collections as well.
Yeah, I mean, there's so many digital resources out there at the moment, and I think what Luca's saying is exactly right. I think previously in traditional cartography, there was the human element was quite often removed or stripped out of kind of especially these kind of very scientific, clinical looking maps. Digital mapping is probably a way where you can kind of integrate more human experience, but it's got to be done in a way that's right, I think, and engaging. Participatory mapping is a good example. I think part of the problem, if you like, is sometimes capturing this information and integrating it into your collections, because digital mapping can be very transient. So there are a lot of challenges about how we archive that material and how we continue to make it accessible in years to come. not sure if that quite answers the question. I think we would always try as map curators to kind of answer a spatial inquiry, and whether that's from items, physical or printed items in your collection, or whether that's signposting someone to other resources, whether they be digital, online, CD-ROM, you know, that is, we would kind of see that as part of our role.
Thank you very much. And there has been lots of praise for the case study, which I will convey, that is collected and will be forwarded later on. And a few questions have been also, I think these are more general questions about methods and the ways that these are not only things that help us answer questions, but also things that generate new questions. So if I would like to wrap up these different questions that have come there, I think it's about how working with digital methods has changed your approach, your research practice in spatial history, Luca.
Yeah, I think spatial history, as it's been done since the early 2000s, has always had a strong emphasis on mapping. Perhaps I would say what is important to me in this project is rather than just plotting data in a historical GIS and making the data available, and kind of the combining different data produced at different times and data that might not normally find its way on the same screen, which has long been a very established way of doing spatial historical scholarship. I think my concern here is distinctly cartographic, and that builds quite a bit on the work that people like Bill Rankin and Anne-Kelly Knowles have done, where there really is an emphasis on visual argument as a worthwhile intellectual endeavor in its own right. I would say, at least for this project, this is a point that is yeah, that I would say is perhaps the most methodologically, perhaps the most important, most important to me here.
Thank you very much. On this inspiring note, I have to move towards the closing message because I know that we are running already a few minutes over time. We'd really like to thank you both, Luca and Donna, for this really fantastic presentation. Thank you so much. Also to all your audience questions and comments. I'd also like to thank, as always, our tireless tech team who made all of this possible. And our next seminar will take place on the 25th of April, so in a week. Amelia Bonnier will team up with Tabitha Tuckett for a seminar entitled Fossil Histories in the Archives. You can find more details about this on the What's On page on the Rylands website, and you can register from there with the Eventbrite link. For now, thank you all for joining us, and we very much hope to see you all again next week. Thank you very much.